Hey guys, today we're going to talk about some concepts that will help you on your NCLE examination. Some basic fitting principles, kind of some hot tips that'll help you navigate through the exam. So we're going to cover a lot of material in a short amount of time. So let's kind of dig in. So there's three things that you really want to look for first when doing any type of question that's related to what type of contact lens should I fit. The first thing you need to know is that the prescription has to present itself in minus cylinder form, but sometimes you'll see it in plus cylinder form, so you have to know how to change that. So let's look at a quick example of that. So if you have minus 250 plus 1 axis 180, so as we can see here, it's in plus cylinder form because that cylinder has a plus value assigned to it. So we have to transpose the prescription. So right off the bat, if this is a fitting question, you're gonna want to transpose this. So we add our cylinder to our sphere algebraically. So that would give us a minus 150, right? Because a plus 1 and minus 250 leaves us with minus 150. You're gonna change the sign of the cylinder and just drop it down. Then the last thing to remember is to rotate the axis 90 degrees. So 180 here would become axis 90. Right, that's a lot prettier for us to work with. Right, we don't want to work with that plus cylinder. So that's the first step when you're looking at these equations. The next thing that's really important to do is to know that if your sphere power is 4 diopters or greater, we have to consider vertex distance. Vertex distance is the refractive distance, which would be the 4-opter or a pair of glasses sitting off of the eye, the distance between the front of your cornea to the back of that eyeglass lens or the back of that 4-opter. So we have to consider that with contact lenses. A contact lens will always be fit more plus than an eyeglass prescription. For example, commonly, if someone's prescribed a -4 spherical glasses prescription, a lot of times they'll be fit with a -375 spherical contact lens because we're making it less minus, more plus, because all lenses behave more plus sitting off of the eye. So with contact lenses, we have to compensate for the fact that we know that when someone's being refracted, that lens is out here. So we're putting it on the eye and we're making it more plus. So if it's 4 diopters or greater, that could be plus or minus 4. You have to make it more plus to compensate for the vertex distance. And it's not exaggerated, so you could have a -10 prescription, and really when you compensate for vertex distance, making it more plus, it's really going to be only about a -9 or so. So never go with an exaggerated answer, but the important thing is to know that you're making it more plus when you're turning it into a contact lens prescription. And the third step when you're evaluating these types of questions is to evaluate the K readings. To evaluate the K readings in relationship to the refraction. And let me draw that up here for you. So if you have K readings, it'll look something like this. What you have to recognize, where this is 42/44 at 180, this is talking about the steepness of the cornea. So what it's showing is, it's showing the flattest and the steepest meridian of the cornea. And what we have here is a 2 diopter difference in those two powers. That reveals, your K readings reveal your corneal astigmatism. So it's showing the difference in the steepness in that prescription, the greatest difference. So what this means, when you take that into effect with the prescription, let's say your prescription is -1, -3, axis 90. So if this is showing that there's 3 diopters of astigmatism and your K readings are revealing that there's 2 diopters of astigmatism on the cornea, that means that there's 1 diopter of lenticular or internal astigmatism. That's going to be important to know the difference between corneal astigmatism and lenticular or an internal astigmatism as you work through these problems. So some facts that you want to know that are going to help you answer some of these. Well, before that, so if the question says that to fit this lens, half a diopter flatter than K or half a diopter steeper than K, whenever you see that steeper than or flatter than K, you have to think of an acronym SAM or FAP, F-A-P. Steeper add minus, flatter add plus. So whenever you get your final sphere power, you want to, if it says steeper than K, you're going to steeper add minus, you're going to add that half a diopter, or if it says 1 diopter steeper than K, you're going to add that, whatever that says, you're going to add that to your final sphere power. Same with flatter. If it says to fit it 1 diopter flatter than K, get your final answer, then think flatter add plus, and then add that 1 diopter to whatever your answer is. But something that's really interesting about gas permeable lenses when you're fitting them is that a spherical gas permeable lens can be fit on a cornea that has up to 3 diopters of with the rule of astigmatism, and it'll correct for that corneal astigmatism. And a spherical gas permeable lens can be fit for up to 2 diopters of against the rule of astigmatism. It's important to be able to recognize what with the rule and against the rule of astigmatism looks like. With the rule of astigmatism, you could think of as a football kind of laying on the ground, where that 90-degree meridian is the steepest. So it's going to be your strongest power on the 90 and your flattest on the 180. Or it could be within 30 degrees of that and still be considered with the rule. So because a gas permeable lens allows for the tear film to come behind it and fills in those corneal irregularities, you could use a spherical gas permeable lens to correct for up to 3 diopters of with the rule astigmatism, and again up to 2 diopters of against the rule astigmatism. And interestingly, you may see a question where it shows that there's corneal astigmatism in the K readings, let's say 42, 43, 50 K readings, which would reveal what, 1.5 diopters, I know you can't see that, 1.5 diopters of corneal astigmatism, right? Because that's just the difference in the dioptric strength of the cornea at the steepest and the flattest meridian. So this is showing 1.5 diopters of corneal astigmatism in here. But if the refraction reveals that there's no astigmatism present, let's say this person's refracted at a -2 sphere, you may quickly answer this and say, oh, I'm going to use a spherical gas permeable because it could take care of 1.5 diopters of astigmatism. Well, what'll happen is you'll actually induce astigmatism because the final refraction shows that there's no astigmatism. So what would happen is that gas permeable lens would sit on the eye, and that tear film would come in and it would actually induce astigmatism where it would fill in the gap between the steepest and flattest meridians. Because what's happening in this example is the inside of the eye, the crystalline lens, there must be a lenticular type astigmatism that is counterbalancing this K reading. So even though if we were just looking at the cornea on its own, we would think, oh, they have astigmatism, but it doesn't manifest in the refraction, that -2. So we'd have to be careful not to use a gas permeable in this instance because it's actually going to induce astigmatism. So you'd be much safer with the HEMA, just soft -2 lens that's going to drape the cornea, and it's not going to allow for the tear film to create that artificial lens. I hope these tips were helpful. Subscribe to the channel, like it, comment. I'd love to hear your comments and request other videos. I'm going to try and keep producing some content so we can learn together and grow in our knowledge of contact lenses. Thank you all.